This is Justin Higgins with Minutes of Teaching. In this video, we are going to explore where our atmosphere ends and where space begins. What is space? How that relates to atmospheric density and the accepted boundary of where space starts, the Kármán line. Space is pretty empty. Here on Earth, it's hard to imagine not being surrounded by a constant swarm of invisible particles. We can feel those particles by spreading out our hands and shaking them like this. Whew! Did you feel that? What you felt is the atmosphere of Earth. The atmosphere is like an ocean of gas that we live in. This ocean of gas allows us to breathe because we evolved to use oxygen at a density that is not that much less than sea level, which is why we need to take extra oxygen with us in the form of oxygen tanks when we climb tall mountains like Mount Everest, and why you see fighter pilots wearing oxygen masks, because the pilots are flying at extreme heights and there's not enough oxygen for them not to pass out. The molecules of oxygen become more spread out at a higher altitude, and space has molecules and atoms separated by so much, basically nothing. Emptiness. Only 6 protons, most likely helium or hydrogen atoms, fill up an entire cubic meter of true outer space. So for our understanding of space, space is where there is a lack of matter. In space, there are very few atoms of matter per cubic meter, compared to on Earth at sea level, where there are about 2.7 to the 25th power atoms or molecules per cubic meter. That's a mind-boggling huge number, a 27 followed by 24 zeros. This is like saying if we took all the sand on all the beaches and deserts in the world and piled it in a great big pile, a single grain of sand would contain more matter than the vacuum of space compared to all the other sand for the entire Earth. And that's making a huge assumption that we are only talking about the smallest element, probably hydrogen, maybe a little bit of helium thrown in. Space is empty. Lucky for us, matter likes to clump together due to gravity, which is why we have atmospheric density. The gravity of Earth attracts all the gases that make up our atmosphere, compressing it the closer we get to Earth's surface. It compresses so much that this much mass, 15 pounds, 7 kilograms, is pressing on every square inch, 2.5 centimeters squared, of our bodies at sea level. When we observe atmospheric density, it becomes exponentially less and less the further we get from the surface of Earth, due to the universal gas constant. It may not be apparent while standing on the surface of the Earth, but if you've ever been on an airplane flight, you have felt the gases of Earth becoming further apart. This is why our ears pop. Or when we drive up into the mountains, the atmospheric density decreases exponentially as we get further from the Earth's surface. Again, our ears pop. Did you know that we can make our ears pop by yawning? And when we talk about yawning, other people tend to yawn with us. The further we get from Earth's surface, the less the Earth's gravity compresses the gases around us, and the closer to space we get. There really isn't an end to this relationship. There will always be some gases around us, no matter how far we are from Earth. The question is, where does space start? As humans, we need a defined line between our atmosphere and space, just like a finish line. And this line is determined by the Kármán line. The Kármán line is the point where using the atmosphere to fly, like airplanes, stops working. Airplanes use the difference in pressure between the top and bottom of their wings while they move. If there's not enough pressure, there can't be a difference in pressure and your airplane isn't going to fly. At about 100 kilometers above our planet, you stop being able to use the atmospheric density of Earth to allow for flight and start to mix lines between an airplane and a rocket that has enough velocity to achieve orbit. Concept
Review.
Space is the absence of molecules and atoms. The further apart the particles get from each other, the more in space we are. Our atmospheric density decreases exponentially as we leave the Earth. This is why we need oxygen tanks to climb Mount Everest. The further we get from the surface of Earth, the less atmosphere there is, and the closer to space we are. We need a point where the atmosphere becomes unusable and we can say that we're in space. And this is the Kármán line. At the Kármán line, we can't use the atmosphere to make airplanes work. At this line, about 100 kilometers above sea level, there is not enough atmospheric density to distinguish between winged flight and a rocket escaping the Earth. I hope you've learned something about where space begins and the Earth's atmosphere ends, and can see where science is in everything.